Hi, I'm Andrew. Today I'm going to give you a quick walkthrough of the resource utilization and capacity planning work that we're carrying out on GitLab.com. I'm going to start off by explaining why I think this is useful using a true story. June was a bad month for GitLab.com. We were hit by a string of separate but related issues which had a severe impact on the performance of the site during the month. In June, we only managed to attain our service level objectives about 89% of the time. And some of the issues were related to Postgres, some to our Redis cache instance, and some to our Redis persistence instance. And I've included some links to some of those issues over here. Broadly speaking, most of the incidents we experience on GitLab.com, or that we do experience on GitLab.com, can be broken down into one of three categories. From most prevalent to least, they are application changes, and this is when a change is deployed to the application and works well on a developer's machine and it passes the QA process, but we're unable to scale sufficiently to handle GitLab.com traffic. And this is by far the most prevalent class of degradation that we see on GitLab.com. The second most likely is a user or a user action, and this is when a user or group of users overloads a fragile component of the application, leading to performance degradation and outages. This can sometimes be abuse, but usually it is unintentional. And the third class is infrastructure changes. And this is when a change is made to the underlying infrastructure and this doesn't scale. So we might make a change to Postgres or Redis and then find out that due to some unforeseen circumstance, it doesn't work as we expected. And of course, there's a long tail of other issues, including cloud provider related issues, etc. But these are the three main categories of issue that we've had to deal with up to now on GitLab.com. So in order to monitor incidents, the two key metrics that we observe for each service are error ratios, and this indicates a percentage of requests that results in a server-side error. So an error ratio of 1% indicates that one request out of every 100 that is made to service will fail with some sort of server-side error. And the second key metric is the Applix score. This is a measure of the percentage of requests that complete within a satisfactory amount of time. So for example, when 95% of user requests complete within a threshold duration that we deem to be acceptable, say within 1 second, the service will have an Applix score of 95%. The June incidents I mentioned previously didn't fit into these categories. They didn't appear to be related to a single change or to a small set of changes in the application. No infrastructure changes had taken place, and for the most part, user action did not appear to be part of the problem. In each of these instances, what had happened was that we reached the capacity limit on a particular resource. Once these capacity limits were reached, the system started performing badly. These resources included PG bouncer connection pools, Redis CPU, and Unicorn workers. When we're utilizing a resource at or above capacity, we call this saturation. There are many ways to reach saturation, but you only need to reach saturation in one area of the application in order to see degradation. What's interesting is that as you reach saturation, things don't fail gradually. Instead, they often fail catastrophically. So using our parlance, here's an example of a wind turbine reaching and exceeding its rotational velocity saturation point. Now the problem is that using the two key metrics that we rely on for determining the health of our services, the Applix and error ratios, they didn't gradually get worse as we approached saturation. And this is the Applix measurement for GitLab's web service in the second week of June. The dotted red line is our threshold SLO. When the Applix is above this value, we consider the service to be healthy, and below this value, we consider degraded. Like the wind turbine disintegrating, the quality of the service rapidly deteriorated, and it became apparent only once it was too late to take action to prevent the issue from affecting users. So how do we avoid this happening again in future? By introducing a third key metric for each service. and this we call saturation. Saturation is pretty simple to understand. For any given resource, what percentage of the maximum utilization for that metric are we currently consuming? So for each service in the application, we can start tracking a set of appropriate saturation metrics. Some of the saturation metrics we track include workers, disk utilization, several different CPU metrics, database pools, and others, and many more are to follow. So here are the saturation metrics for the GitLab.com web service for the past week. Each saturation score has a different profile. Some, like disk utilization, are very flat, while others, like CPU, can be quite spiky. Now that we have these metrics, we can start alerting on any resource exceeding a value of, say, 90% for a period of, say, 10 minutes. And this is already a big improvement over the previous alerting rules that we were using, which tended to be quite piecemeal. So while we had some CPU alerts, we didn't, for example, have any alerts covering single-threaded CPU utilization on Redis or single-node CPU utilization on Sidekick. With these alerts, we now cover that and many other cases that weren't previously covered. So after we've got alerting sorted, so that we can know of immediate problems, the next step is to build out a long-term forecasting model. What we've realized during the troubles in June was that once we hit capacity, it was already too late. So many of the fixes for the resource utilization problems required application changes to inefficient, unscalable features. And these changes might take at a minimum several days to isolate, fix, and test. So it's crucial that we're able to forecast saturation problems well in advance of the saturation event so that we have time to improve the application or scale our infrastructure. So how do we do this? A naive approach would be to linearly interpolate our resource utilization to predict when it's going to reach saturation. Unfortunately, most resources are too spiky. Take, for example, the single core utilization on our Redis fleet. This chart is taken from a period of the June troubles. So CPU was routinely spiking up to 100%, which is a very bad thing, and was one of the reasons we were seeing dismal web performance. The dotted line, however, shows the rolling weekly average for this metric. This graph is almost flat. If we were to linearly interpolate on this, it would indicate that in 1 month's time, average CPU would be at about 76%, which doesn't sound that bad. Now, this isn't a very good forecast model because it uses the average, which barely moves, while the number of spikes up to 100% was actually increasing. So instead of interpolating directly on the value of the metric, a better approach might be to divide resource utilization up into 3 zones: green, warning, and saturation. This is based on the concept of Applix, but applied to saturation. This is why I sometimes refer to this as saturation Applix or a SAPDEX score. When a saturation metric is below, say, 80%, we say it's in the green zone. Above 80%, it's entered the warning zone, and when it exceeds 90%, it's entered the saturation zone. We then score the metric for the amount of time it spends in each zone. In the saturation zone, it scores 0. In the warning zone, 50%. And in the green zone, it gets a score of 100%. And using the score, we can calculate the average score for the resource over time. This is an advantage over direct linear interpolation in that the metric saturation score will highlight dangerous spikes in resource utilization, even if the average value is not affected. So going back to the previous metric for Redis CPU, let's look at how its SAPDEX score performs over the same period during the troubles in June. The top graph shows a single core CPU utilization, and the bottom graph shows a SAPDEX score for Redis single core CPU. As you can see, the SAPDEX metric is tending down as CPU spikes keep occurring. And using linear interpolation on the SAPDEX value, interpolating 1 month into the future, we can forecast potential resource saturation issues. This should give us more insight into long-term trends, and having 1 month warning should be enough time to allow application changes to be made to avert degradations before they reach saturation. Finally, I'm just going to give a demonstration of how we can view the saturation reports at the moment on GitLab.com. So this is the platform triage page. It shows the health of each service in the application. It shows the key metrics for each service, as well as the saturation. At the bottom, there is a report which gives us different services and their current state. So the first graph gives us resources that are currently at risk of saturation. So here you can see it's telling us that the disk space resource on the Petroni service is nearing its capacity limit. And likewise on the Postgres archive and Postgres delayed services, the same disk space resource is nearing its limit. Interpolating out 1 month into the future, we get the same report on the same resources because this is not being addressed. This is actually something that is currently being addressed. The disks on these machines will be increased soon. So this is something that is being worked on. So let's go take a look at the Petroni service and see what we can see with that service. So I'm going to go to the top and click through to the Petroni service. And again, we're presented with the key service metrics for that service. Again, but instead of seeing them for all services together, we only see it for this individual service. And as you can see here, saturation is at 90%. If we open up the component metrics, we get to see why the saturation metric is at 90%. So what we do with saturation is we aggregate it on the maximum, because if we used, say, the average, you might have 3 resources that are a very low utilization and one that's near the top, but you only need one to be saturated for the service to be saturated. So here you can see that disk space is at 90.96%, and that's what's giving this service a high saturation value. If we increase this to the last 7 days, we can see the growth in that saturation metric. Well, it might take a moment for the graph to update. While we wait for that graph to come back, I will show the capacity planning section of the service dashboard. So what this gives us is it shows the current saturation score for each service in the Petroni service. So here you can see this service has got a disk space resource, a single node CPU resource, memory, and overall CPU. And what it's telling us is that in 1 month's time, the disk space will still be near saturation, but everything else will be fine. And then down below that, we get a long-term saturation trend, which shows us over time for each resource on the Petroni service what it is doing over the last 3 weeks. So we can see that CPU is gradually going up, but is still very low. Disk space has exceeded 90%, but it's growing quite slowly. And then we get the long-term saturation. For this particular service, it isn't very exciting. Most of the resources are at 100% on the SAPDEX score, except for the disk utilization, which is at 50%. But if we switch over to the Redis service, we can actually get a more interesting graph. So let's go in here. Did I click the wrong graph? Okay, I'm just going to go here directly. Seems to be a bit of a problem with that. So Redis was one of the services that we saw some problems recently. If we take this and look over the past, well, so what we have here, which is quite interesting, is this graph over here shows us the SAPTEX score for the Redis single-threaded CPU. And so you can see when we started recording this metric, it was very low, near 50%, which we would consider to be a bad score. But then as we've managed to make application changes that take some of the load off Redis, we've seen this score tend up. And then recently, we actually split our Redis cluster into two, and you can see that this score is now tending up to 100%, which is telling us that Redis is actually doing very well now. Last week, when I was looking at this, what this told us was that the single-threaded CPU was at capacity, and it also told us a 1-month saturation forecast that Redis CPU was going to be at capacity. And because of the changes that we made this weekend, this is now improved. So hopefully next time, before we see a saturation event, these graphs will tell us of the problem. Obviously, we're also going to not only just rely on Grafana dashboards, we're going to create alerts out of that. And that concludes the demonstration. I hope you found this useful. If you have any questions, please get in touch with me. Thanks.